Welcome to my presentation about Eclipse 4. What's next for Eclipse 4? Reflecting a little bit on the history and looking to the future and what we have done at the efxclipse project, which has exchanged the UI rendering technology of Eclipse, replacing S3D with JavaFX. And we invested a lot of time in the runtime layer, and I will present the ideas that we have for the future of Eclipse 4. Well, I'm Tom Schindl. I'm the original author of the Eclipse 4 application platform. So I developed it together with IBM. So I was responsible for the complete application model in the Eclipse 4 story. I'm a committer at the Eclipse Platform and EMF beside that, and I lead the efxclipse project at Eclipse, which deals about JavaFX integration. So when I sat down preparing the talk, I thought, well, what would be interesting is to ask myself questions about Eclipse 4, and I'm trying to answer them and hope that you are learning something from my answers. So, Tom, could you reflect a little bit on Eclipse 4, the Eclipse 4 IDE, and what happened there? And when I created the slide, compat layer, the first thing that happened, that autocorrection kicked in, and out of compat layer, it made compat layer. And I thought that might make sense, because reflecting, you see, we've had a tough fight to get the compat layer running. So it was really a compat. So that's why I found it interesting that autocorrection kicked in. So what's the problem with the compat layer? And I'm not sure whether we made a mistake when we started implementing that. That's something that could be discussed. So if you look at the world, how Eclipse 4 spec'd the world. We spec'd the world that we have a brain, that's the application model. We have a nervous system, that's our dependency injection container and the OSGi service registry. And we have our sense organs, that's the UI. S3D, JavaFX, you name it in the end. What the compat layer did, it violated that and created a split brain. Half information is found in the application model, half is still found in various types of registries. We will meet this again when we talk about editors in Eclipse 4. If you ever tried to build an IDE in Eclipse 4, plain Eclipse 4, it's impossible. The reason is that when we did the compat layer, we dropped off from Eclipse 4 and implemented stuff in the compat layer, or left it in the compat layer in the split brain area, although it should be moved to Eclipse 4. This is the reason why, even if you try today to extend the Eclipse IDE using fragments, for example, is, let me put it this way, you're experimenting. It's an experimental feature, but if I would write commercial code, I would never do that. I would never use that feature. And the main reason is that we still have the split of information between application model and registries. So, as I said, I'm not sure whether we went the right way. We needed a compat layer, but probably we should have done it differently. OK, next question I could ask myself. So, Tom, what's your take on Eclipse 4 core layer and the dependency injection components? So, when you look at how OSGi specs the world, you have a service API. It's a separate bundle with no dependencies. And then you have implementation of this API in their bundles, and they can have various dependencies. That's not a problem. For example, they can depend on Equinox, or they can depend on Felix. They can depend on GPA. They can depend on your logging framework of choice. But the API bundle should never do that. The reason is that if the API bundle has dependencies, you get those dependencies as a consumer by default. You have to live with them. You can't get rid of them. It's impossible. That's how OSGi specs how you should set up your application. But in contrast to that, what we did in Eclipse 4, we created a service API bundle, which has an API, and we put the implementation in this bundle. For example, we have our DI container has a direct dependency on Equinox. You can never run this guy on Felix, although there is no real reason, because the API would be perfectly fine running on Felix. Probably you need a different implementation. But why the hell? So you get, as a consumer, a transitive dependency whenever you, for example, wire yourself against the dependency injection container from Eclipse 4. As I said, want to see an example? That's the bundle specification. Until this point, it's fine. That's the dependency injection container. For sure, it has to use JavaFX inject. For sure, it has to use JavaFX annotation. But the freaking hell, why does it require Equinox lock, OSGi, framework hotel? Why the hell is it using that? And the only reason it has this dependency is that the implementation is, to some extent, or the biggest extent, part of our API bundle. And now you cannot run our dependency injection container, for example, on Felix. Okay. So, next question I could ask. Tom, what's your take on OSGi in Eclipse 4 APIs? Let's take a look at the ideal world. We have an API bundle, which depends on nothing. We have an implementation bundle, also depending on nothing. And we have another implementation, another component bundle that uses our API bundle. So in OSGi, you would define here an interface. You would spec here a component. And you would spec here a second component, which has a reference to the other component. The important thing is here, you don't see any OSGi APIs in this code. It has no compile time dependency on OSGi. That's important. You don't need OSGi in this whole scenario. It's opaque. You don't see it. Let's look how E4 uses OSGi. So the first two things are the same. So you have your interface definition and you have your component. And now if you want to access a component, what you're doing, you write @inject, and the dependency injection container is taking care that it does the injection. So it's the replacement for the @reference annotation we saw in OSGi. That is all good and fine, because still no compile time dependency or runtime dependency on OSGi. But the problem is how we are setting up the dependency injection container. The dependency injection container, we create an instance using the context injection factory make. That's still fine, but the problem is how to get access to the service context. And now you see that you have to have a compile time dependency on OSGi to create an instance using our dependency injection framework for no good reason in the end. So you will see in my final slides. We can now discuss and ask ourselves, or ask, what APIs of OSGi are we using in Eclipse 4? What is your code using? Which OSGi APIs? I think most of your code probably will use no OSGi API at all. Ideally, it only deals with dependency injection, and that's it. All information is coming from this layer. But Eclipse 4 itself has some API usages of OSGi. The first very common one is logging. So we depend, for example, on framework log from Equinox to do logs. Well, on the other hand, we have a lot of Java logging libraries. Most people in your code, you are probably not using OSGi logging. You're using log4j or SLF4j, or you name it in the end. But we internally are using this very special Equinox logging infrastructure, which has not all the features you're used to from your log4j, for example. But we're using it. So that's the first thing where we depend on OSGi APIs. And the second thing is accessing services. Whenever we search for a service in the system, we go out to the service registry of OSGi, look the service up, and inject it into your beans. These are the predominant uses of OSGi API in our E4 core layer. And the UI layer has only 2 or 3 more of them. It's not that much. So the next question you could ask, okay, if that's so few, can we get rid of them? Is it possible? Can we do that? So the first thing that you need to have is a decent logger. A decent logger API, a modern logger API. You could go for SLF4j, you could go for log4j. That's fine. Our decision at efxclipse was that we create our own API. There are reasons to that, and you will see them in a few minutes. First thing, what you need to provide is you need to provide people a common pattern to get to a logger. This is how a component in the early 2000s accesses a logger. If you are working in the OSGi world, you want to get access to a logger by using decorative services. You need a factory and create a logger. And if you are a dependency injection component, all you want to write is @inject, @log, get a logger. Done. That's how modern code looks like. So we want to have an API that allows us to use those access patterns. And we want to have a decent API that we can use for logging. If you look at this log statement, and if you look at the method, it's process GPA results. And what you see here with p.getAddress, what happens here, most likely in a GPA world, that this is a bad idea because this object by default is lazily loaded. So you go out to the database, load an object to construct the debug message, only to find out that you are not running in debug mode. So you pay all the overhead. So in traditional frameworks until yet, what you had an if statement around that to find out if you are in log, and then if the creation of the log statement is very expensive, you guard that with an if clause. In a modern world where we have lambda expressions, we want to have an API that looks like that. This is a lambda, a so-called supplier. So you see the API up there. So this supplier is only calls its lambda expression method if we find out in the debug method that we are in debug mode. So we delayed the creation of the statement just by this. Or better, we have another debug where you pass in a parameter and point it to a function. Looks complex, but this guy is 10 times better than the supplier version. Because what you're creating here is a so-called, you're capturing, you have a capturing lambda, what you created up there. You're capturing the B from the outer scope. Bad idea. Why is that a bad idea? It looks so innocent, but if you translate that to code that you are familiar with, this is the code that in the end is executed. Well, it's not reality, but this is how you could translate that to inner classes in the end. So what you're doing here, you create an instance with every loop. So if you have a loop with 1,000 entries, you create 1,000 supplier objects all the time. Because when the lambda factory goes out, it creates such a class at runtime, and creates an instance all the time because you're capturing the P. If you compare that to the version with the method, we are not capturing anymore. So the lambda or the VM can be smart enough and it creates only one instance and passes all the time the same instance to the debug function. So we save 1,000 object instances all the time when we ever run this code. And we took care that this guy can be used in streams because our method, the parameter you pass in, we return that. So you can add in between your stream calls, you can log informations in the end. So that's what I expect from a modern logging API. And there is no such API around on the world. Hence, we created our own one. Good. Then what can we do about service lookups? Well, when you look at Eclipse 4, the first thing that you see is, well, getting access to a service is fairly easy. All you need to do in your component, add inject, you get the service injected. That's perfectly fine. But what if you want to have all services that are available in the OSGi service registry? You would like to write something like that. But that's not possible using the default dependency injection container in Eclipse. It will look up something Java util list in your context in the end. And this will not work. So what we have in efxclipse, what we created is, we created a special annotation. If you annotate an add inject field method with add service, this annotation makes sure that you are following the OSGi semantics. So the requester of the service is really this class and this bundle. So you can use of service factories. Or component factories, component factories, sorry. You can deal with services coming and going. It reflects the dynamics of OSGi. It gives you, if a higher ranked service comes along, it will inject the higher ranked service. So it really follows the semantics of OSGi and its runtime model. And the perfect and great thing is, you can now let the dependency injection container inject you a list of services. The trick here is not all, well, people always think that when you have generics, that all information is gone in the class file, but that's not true. There's still information there. So when we find out that you have a list, we look at the type parameter here and query the OSGi service registry with exactly this type. So now you can use OSGi services in a dynamic environment using the dependency injection container. You notice we never talked about JavaFX. This is efxclipse, what I'm leading, but this is our core runtime layer. You can use that in any application, whether it is Eclipse 4 SWT, Eclipse 4 on the server, we don't care. This is a runtime layer we're talking about here. But what when we do static lookups? Okay, a static lookup in Eclipse 4 is through the IEclipseContext. So getting access to a service or component is c.get. But what if you want to look multiple of them? Impossible. There is no expression for an EclipseContext get that gives you a list. On the other hand, what we have at efxclipse, we have a helper utility. It's called Servicelookup, and you call get service. First of all, it returns an optional. The reason is, once more, in OSGi, something can be there, but it must not be there, and you express that in Java 8 using optional, so that you don't run the risk of a null pointer exception. You make that explicit through your APIs. Or if you want to have a list, you call get list. And the cool thing about this guy is, it works in OSGi, and it works outside of OSGi. So you can use this guy, the lookup services, in a standard Java environment and in an OSGi environment. On OSGi, we delegate to the OSGi service registry. For plain Java, we have our own small implementation, reading component XML files, creating instances, wiring everything together. So still no dependency. So if you follow my blogs and all this stuff, you see, well, I showed IEclipseContext. And something that I'm really, really keen on is that you are writing code that is free of IEclipseContext. I don't want to see code when I go to customers who references in the business code IEclipseContext. That's a big, big mistake. It violates the principles of the dependency injection world that we created for you. The problem is we stopped at a certain level, but we will see solutions to that in a minute. So retrieving and publishing information in Eclipse 4. Let's set up an Eclipse context structure. So we have an IEclipseContext, which is the parent context having our person object. It's a window context because you have the model element of the window in there, and you have a part context. So getting access to an information of the context is easy, and we thought about that when we created the dependency injection container. All you need to do is add inject, and everything will work happily. The problem starts at the point where you are required to publish something. Probably you have a list of persons, you select someone, and you want to publish this information. Eclipse 4, proper Eclipse 4, doesn't give you any support on publishing information unless you reference the IEclipseContext. But that's a very bad idea. First, the problem you see here, in your bean, you encode the hierarchy of services of IEclipseContext. So you say get parent to get to the parent context, but what if in there between is you're introducing a perspective? Then you're publishing information in the wrong context. And you make your business code depending on Eclipse 4. It cannot run without Eclipse 4 anymore. But the purpose of a dependency injection container was to free your business code from dependency to a framework. So that doesn't match in the end. But if you think about that, what we are specifying in here, we are defining a slot in the service context. Injection means in the observer pattern, we are observing the value in the context, and down here, we are publishing informations. When you think about that, you find out that there's a solution to this problem. And this is how Eclipse efxclipse runtime layer allows you to access information. Add inject is good, but it allows you to specify a slot in the IEclipseContext, and it gives you a consumer instance, and all you need to do is call accept. This means now your code is free of Eclipse dependencies. All it has is a dependency to a bundle with an annotation at context value. That's it. And the great thing is the adapter framework running in the background can adapt that to an IObserver value, for example, if you're using Eclipse data binding. So it will eject you an IObserver value, which you can directly bind once more to your list or to your detail area in the end. Runtime. Now we talked about the runtime. Once more, this is all stuff available currently at efxclipse. You can simply mix that into your target and use it in your RCP S3 applications to make your code, business code, better. Now let's switch a little bit to JavaFX. There are always rumors that JavaFX is dying and everything is so bad and whatnot. So, what is the quality of your JavaFX renderer, and do you have public success stories on that? Okay, let's see if you have a good success story for you. This is the success story. We are currently working with the German government, Department of Justice, on an application written on JavaFX, plus 100 developers, budget over 100 million euros. It's for Department of justice in this case. It's called form star. So they are betting on efxclipse, JavaFX on Eclipse 4. That's one of our publicly available stories. You can read about the project at this URL in the end. To show you how such an application looks like, let's see, I have recorded a small video for you. Is it running? Yeah. So you have a start mask similar to Google. You can find trails in there in the end. So if you are suing someone, then you can, it's a database frontend in the end, so you can do things like adding people to the thing. You have the calendar control, allowing you to create or use your calendar, your personal calendar. This is an application we've written in the last 2 months. It was two-man months in the end, because it was just me who wrote this thing. So just to give you an idea what can be done with this platform. What's very important when we talk about project for the government is things like high contrast mode, accessibility, and all this stuff. And this works perfectly fine with JavaFX. I even talked to Steve Nordover. He did the accessibility implementation for SWT, and he did the one for JavaFX, because he was hired by Oracle to do that. And what he told me is the mistakes he made in SWT, he haven't made in JavaFX. And the JavaFX one is really better than the SWT one. It's strange, but that's the way it is. I cannot change that. So let's talk about the future. What's cooking in efxclipse? What's cooking for the platform? As you see, we always think about first efxclipse, but then also that you can use that in your Eclipse 4 application. Whether we move that back to Eclipse project, it always depends on whether there are resources at the Eclipse project who are interested in it and willing to help me build a foundation. But everything we developing can be used in your applications as well. Let's talk about the editor story in Eclipse 4. The problem is there is none. Eclipse 4 has no notion of editors. The reason is that it's just the component layer in the Eclipse IDE that deals with editing all the stuff with a text editor, with your source code editor. That's all encoded in the component layer, but not at the E4 layer. So, what's the trick about, or what's the efxclipse story? So, we have our application platform. Then we created a core API that, for example, abstracts away the file system and all the stuff. And we have a presentation API. Then we have implementation of our core abstraction layer for Eclipse file system, iFile, iProject, and all the stuff, and for plain Java, using Neo in the end. So you are not forced to have a workspace for our editor framework. That's the main idea in the end. It should be lightweight. And we have implementations for JavaFX. There is the possibility to write an SVD one, but it doesn't exist. Nobody took the time to implement that. But it is available. And once more, this framework can be run on JavaFX, Eclipse 4, and on Eclipse 4 with SWT. Want to see an application built on top of that? Application built by SIG. And you see here we have rulers on the left-hand side. We have debugging breakpoints. You have special information about the runtime information, so you can control all this stuff that you're used to from your Eclipse environment. But this is how a modern IDE for development looks like. Yeah. And I recorded you a small video showing you the application that's not only a mock-up, but it's a real application that's really working. So they're using Lua for scripting their devices. You see auto-completion, you see hovering, working, all the stuff that you're used to is available through the framework, through APIs that we provide. And they just plug themselves into this, into our API. Okay. Perfect. So next question we could ask. So now that we stripped off all the OSGi stuff from our core layer, can we in future probably run Eclipse 4 applications without OSGi? And if we don't use OSGi, can we use IntelliJ? Can we use the Dracula theme? That's a question. And I'm producing runtimes. I'm not producing IDEs. So if my customer wants to use IntelliJ, go for it, buy it, and live with it. Well, it's up to you. I, as a runtime developer, think, or framework developer think, no, I don't want to force you to use OSGi. I think it's a perfect model for developing applications, but I will not enforce it on you. And the same is true for the IDE. I think Eclipse is the better IDE. But if you think IntelliJ, NetBeans, or whatever IDE is better, use it, go for it. It's not my business. So no, but only for Eclipse 4 on JavaFX. I can guarantee in future, in 1 year, you are not forced anymore to run on OSGi, and you are not forced to use Eclipse. So how does the platform of the future look like? So we have the JVM, we have OSGi. That's today. The Eclipse platform, and there is the efxclipse core layer. Currently, they are on the same level. Eclipse 4 platform and core layer on the same level. And on top of that is the efxclipse platform with all specialized services. In future, we will make that look like this. The efxclipse core layer is replacing or in between the 4 application framework and the JVM. Whether you mix OSGi in there or Java 9 modules or no modules and you go with Maven, I'm fine with that. The framework doesn't care about that. And can that really be done? So what I have recorded here is I've taken the core runtime of Eclipse and stripped out OSGi from the core bundles, from the dependency injection container and from the core context thing. You see here, I used a so-called fragment to stay API compatible. So I'm not breaking APIs. That's what I'm demonstrating here. Everything that runs on OSGi is still running. Everything good and fine. I'm using the extensible API header. It's a very special thing. Yeah, well, there's a reason to that. So the reason is that I want to stay completely compatible without rearranging too much code. Having the same class loader, that's why I'm using fragments. I have a new service to create our context function. I have an implementation for OSGi. I have an implementation for plain Java of this guy. And now I run the test suite of the core. And the test suite, when it's running, it takes some time on my laptop to boot up. But when it's done, no test failures. This means my refactoring was successful. No bundle that had compile dependencies or runtime dependencies on the code is broken, and the unit tests are still running. And now, what I promised is, because this is all not using OSGi anymore, or it doesn't have to use OSGi anymore, I can run that guy if I start the video. I can use Maven with Maven dependencies, and for that, that you not think that I'm faking that, I'm doing that in IntelliJ. So I have the dependencies on the dependency injection container of Eclipse. our core layer of efxclipse in the end, who does all the magic with the runtime. And now I can start implementing or bootstrapping my dependency injection container in a plain Java environment. And it works completely the same than it would in an OSGi environment. The only thing it misses, it has no dynamics. Well, that's what OSGi brings to the table, dynamics in the end. So I create the context. Time, OK. Almost up. Creating our service context. I'm not that good at typing in IntelliJ. I'm much faster in Eclipse. I don't know all the keyboard shortcuts, but anyways, I got it working. And storing a value. Then the last thing must be to create an instance of this guy. And instance is there. Storing it. I did a lot of copy and paste because the shortcuts are missing. And finally, we have the component and call test, and then in a IntelliJ, run it, and it really does the compilation when I run it. So it takes some time. You see calling make. And finally, we have the dependency injection container working, using all the specialized things with add lock annotations, context functions. All this stuff is working magically in plain Java. This means in future, you will be able to run efxclipse E4 JavaFX applications on plain Java. So last question, are you planning a fork? Not necessarily, but if I have to, I will. So I don't want to let efxclipse stop just because the platform, for example, decides that it's not the right way to go. That's it. Sounds brutal, but that's the way it is. OK, so I'm open for questions now. Thanks for listening. Any questions? Yes?
Are we able to ship JavaFX instead of open source?
Once more?
Are we able to ship JavaFX in open source?
You mean ship JavaFX as part of Eclipse?